So this is a single slit problem. Remember, I'm going to give you this little pattern here. Remember that in terms of sine theta, right? This is lambda over d, where d is the diameter or the width of the slit, right? This is another lambda over d. This is another lambda over d, right? So from here to here is 1, 2, 3 lambda over d. This is 4 lambda over d, right, equals sine theta, right? So the first thing you really want to do with these is you want to figure out what your number sentence is, right? So here they're saying the center of the central maximum, right? So that's here, right? To the center of the first maximum on one side. Well, this is the first minimum. Here's the first maximum, the second minimum, the second maximum, the third minimum, the third maximum, etc., right? So I'll always say the central maximum, right? And then this is the center of the first maximum is here, right? Okay. So now we're good, right? This is lambda over d, and then this is another half lambda over d to the center of that one, right? All the way to here would be 2 lambda over d, right? So what I'm going to do is I'm going to say sine theta is equal to 1 1/2 lambda over d. And that comes from it going from here to here, right? So that's lambda over d, and then another half lambda over d is this little bit here, right? Lambda over d, another half lambda over d, okay? Because I mean, that's really the only hard thing about this, right? And then what are we trying to, we're trying to find the angle, right? So the angle here is going to be inverse sine of 1.5 times the wavelength over the slit width, right? So that's inverse sine of, let's see, 1.5, whoops, 1.5, ignore that thing there, okay, times 550 e minus 9, right? All divided by d. D is 0.0215. Notice that that's millimeters, right? Millimeter is 10 to the minus third meters, right? So I'm just going to go times 10 to the minus third, and I'm all set, right? Now, obviously, you could sit there and try to move the decimal point over 3 places or something like that, but I'm not very good at that, so I just use scientific notation, which is, I think, safer, okay? So now all I have to do is do this. Let me make sure I'm in degrees, and indeed I am. So I'm going to get an angle in degrees here. Inverse sine of 1.5 times the wavelength, 550 times 10 to the minus 9th. Is that right? Yep. Okay, divided by 0.0215 times 10 to the minus 3rd. Don't forget that 10 to the minus 3rd. And I'm getting that it's 2.199098 degrees. So I guess I can say 2.20 degrees. Ta-da. Okay, that's from the center here, right? So wherever that slit is right here, right? And so that angle is 2.20 degrees. Yeah? All right, hope that helps.